Okay, so yeah, just get started on the quiz then.
Pulling that up. Okay, I'm ready.
Okay. So we'll need the following data files. Pull that up. Okay. Alrighty. Use the following information for the next two questions. Suppose we have a set of paired data and let D equals X after minus X before. The null hypothesis is the mean difference equals 0. The alternative hypothesis is that it does not equal 0. And the population standard deviation is not known. Jordan collects a sample of size n equals 9 and computes D equals 2.2 and ST equals 3.3. What is the value statistic? Value of the test statistic. So if we do just the T equals formula, right?
Mm-hmm.
So I'm going to scratch paper. Okay. So we do 2.2 minus 0 over 3.3 divided by the square root of 9. So I got 2.
That's what I got too.
Good. For the probability of obtaining a test statistic greater than Jordan's test statistic is 0.043. Use this probability to determine the p-value for Jordan's hypothesis test. Is it just 0.040? Isn't that what the p-value is?
Probability of obtaining the test statistic. Isn't there a probability formula?
I don't know. So when I use the applet, I type in the t-score of 2, and then I just shaded everything above it and put the degrees of freedom as 8, and it says it's 0.0403. So I think that's the p-value.
I can't find any type of formula for this one.
Yeah, I think that's just the p-value. I think the p-value is the probability. I don't know. I'm just going to put that and see what happens. Okay, use the data value 12 data A1 to answer the next 6 questions. Perform a paired samples t-test in Excel. Be sure that the test group 1 Wait, be sure that the test does group 1 minus group 2. There's a null hypothesis, an alternative hypothesis, and level of significance. What is the test statistic? All right, so we do group 1 minus group 2. Of course, my thing's going to freeze. Here we go. I got 0.407.
Okay. I'm almost done.
Okay.
So you got 0. What?
0.407.
Because see, for my test statistic, it's giving me 0.345.
0.345.
Mm-hmm.
Do you have the null hypothesis set as 0
Yeah.
and confidence level 0.95?
Yeah. And we're doing this as not equals to.
Not equal to. How many variables does it list for you?
I'm getting 20.
Okay, me too. I don't know why we'd get something different.
That is weird.
Let me try. Let me go over here.
I'm going to try pulling this up. See if maybe that will give me a difference.
Yeah, what's your list of differences?
I just closed out of everything.
Okay. And you did group 1 minus group 2?
Yeah.
I think I did too. Let me just make sure I did. Group 1 minus group 2.
Okay, there we go. See, I know what I'm doing wrong. See, I'm inputting group 1 and then group 2 individually and then going through it. But if you add it in together, it calculates it all together.
Oh, okay.
Hmm.
So you got 0.407?
Yeah.
Okay. Sweet. So then for the p-value, I got 0.689.
Yeah.
Okay, and so that p-value is greater than the level of significance. So we fail to reject the null.
Yeah.
Okay. Perfect. So question 8, suppose your alternative hypothesis is instead it's greater than 0. What is the correct decision based on this evidence? So if we change it to greater than, excuse me, and not instead of equal to, my p-value says 0.344.
That's what I get.
Okay, great, which is still greater than the level of significance. So we fail to reject again. So if we fail to reject, then we say we have insufficient evidence. Let me think. So
I always get confused on that one. If it's insufficient or sufficient.
So I learned from the video last week, if we fail to reject the null, then we say we have insufficient evidence to say that, and we state the alternative hypothesis. So we have insufficient evidence to say that the mean difference is greater than 0.
Okay, that makes sense.
So it should be the second one.
Uh-huh.
Okay. Sweet. Okay. Question 9. This use the other one. Okay, so I'm gonna pull up chapter 2. Okay. To answer the next 8 questions, perform a paired sample t-test. Be sure that the test does group 1 minus group 2. Okay, again, this data comes from blah, blah, blah. The null hypothesis is that it equals 0. The alternative is that it does not equal 0. And the level of significance is 0.01. Okay, so the first question, which is greater, n or df? And that should be n, right?
Yes.
Yeah, degrees of freedom equals n minus 1.
Yeah.
Okay, what is the p-value? All right, now I need to do this. 1 minus group 2.
That one I'm getting 0.001.
Sorry, let me see. Yeah, me too. 0.001.
Yeah.
Yeah, me too. Okay.
So,
question 11, what decision do you make? So that is
we would
less
fail.
than that. So we reject the null, right?
I mean, it equals the same. No. Yeah, you're right. We would.
Yeah, the p-value is less. So we reject the null. Okay, so you decide to try another alternative hypothesis. This time you use that it's greater than 0 and you keep the same level of significance. Did the p-value increase or decrease? So if it's greater than, it decreased. Do you see that too?
Yeah.
Okay, what decision do you make? Same one, right? So we reject the null?
Yes, because it's still less.
Yeah. Based on your response from the previous question, what conclusion do you make? So we rejected it. So it says that means that we have sufficient evidence to say that, let's see, we have sufficient evidence to say that there is no mean difference between the two groups. We have sufficient evidence to say that there is a mean difference between the two groups. Yeah, it should be that we have sufficient evidence to say there is a mean difference, right?
Uh-huh.
Okay. Yeah, that seems the best to me. As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? Well, let's see. So if we do less than, it would be great. Greater than is really small, not equal to. So I'd say either greater than or we don't have enough information. Does it depend on the problem?
I think it does depend on the problem.
Okay, should we say it depends on the problem?
Yeah.
Okay. Okay. Determine the 95% confidence interval for the mean difference between the two groups using group 1 minus group 2 and put your answers below. What is the point estimate for this 95% confidence interval? And that would be, that's the t-score, right?
Yes.
Or the mean. I think it's actually the mean.
Yeah, because the point difference for the t-score would be the mean.
Yeah, so the point estimator is the mean. So it's 11.955.
Yeah.
Right?
Uh-huh.
Okay. 11.955. What is the margin of error for this 95% confidence interval? So I emailed her how to do this because I keep missing this on the homework quizzes. So let me pull up the email and see, unless you already know how to do it, but I didn't understand this. Okay, so she says when you are given the confidence interval, then you use it to find the margin of error. So you take the upper confidence level minus the lower confidence level and divide that value by 2. And then if we are not given the confidence interval, then we use the formula that we thought it was last time. So we do the upper minus the lower and divide by 2. So it should be 18.607 minus 5.303 divided by 2. So I think it's 6.652.
Okay. Hold on.
So hopefully that's right, because I did not know what to do there.
Yeah, 6.652 is what you got?
Yeah.
Yeah, that's what I got too.
Perfect. Input the lower bound, 5.303. Input the upper bound, 18.607. Sweet. Let's see if we did that right. Dang, okay, I got the p-score wrong for the second question. Oh, that was it. Everything else we got right. So it's not enough information, depends on the problem. I'm going to have to remember that. Okay, well, the probability of obtaining a test statistic greater than Jordan's test statistic is that. Use the probability to determine the p-value for Jordan's hypothesis test. Oh, I see what we did wrong there.
For the second one?
Yeah, so that was if it was going to be greater, but his hypothesis is that it could be either. So do we just subtract 1 minus that? That seems really high.
A statistic greater than.
Okay, wait, let me go back to what are we doing? Oh yeah, okay. So if we get greater than, that's what it is. So use this probability to determine the p-value for Jordan's hypothesis, which is that it does not equal. I don't know what to do there.
I'm not sure either.
Probability of obtaining a test statistic greater than Jordan's test statistic is that. Use this probability to determine the p-value for Jordan's hypothesis test. So it does not equal 0. Oh, maybe we highlight both greater than and lower than, lesser than. So then it's 0.0805. I think I'm going to put that and see what happens. Otherwise, I don't really know what else to do there.
Amazing.
So I'm just going to try that and see what happens.
Doesn't hurt.
What?
I said it does not hurt to try.
Oh, okay. Yeah, I don't think so. So I'm just going to do that.
Yeah. I guess if not, then I think tutors are still there to chat with until 11. You can always chat with a tutor.
Okay, that's a good idea. hate retyping everything back in there.
I know, right?
I guess it's better than figuring it all out again.
Mm-hmm.
Yeah, okay, that was the right answer.
Was it?
Yeah.
Yay.
Okay, good. Yay, we figured it out.
Yeah.
Good. All right, well then, I guess we're good.
Alright, I'll see you on Thursday then.
Good, sounds good. See you later.
Yeah.
Bye.